Hey, welcome back. Hope you had a good Tuesday. And now we're going to move on to talk about the quadratic formula, using it, and then looking at the piece called the discriminant that will tell us how many solutions and the types that we can expect. So when we're using the quadratic formula to solve, we want to make sure that we know what A, B, and C are. A is the coefficient in front of x squared. B is the coefficient in front of x, and C is the constant. Notice that all of the terms are on one side. All on one side. That's super important. All right, this is the formula up top here. Important to know. Okay, we kind of made a pact that we would know that before the end of the year, before we graduated and walked across the stage. So I'm still holding you to it. And now what we're going to do is we're just going to plug in. So I have negative 5 plus or minus the square root of b squared is 25 minus 4 times 5 times 2 all over 2 times 5, which is 10. So now we're going to start by simplifying the inside of our radical sign first. And when we do this, this is x equals, and we have negative 5 plus or minus the square root of, this is 25 minus 40 all over 10, which equals, I'm going to go to the right here, negative 5 plus or minus the square root of negative 15 all over 10. Now we know what to do with a negative inside the radical. We know what to do with that. We've seen it before. We're going to take it out as an I and simplify that radical. So we get negative 5 plus or minus I root 15 all over 10. And that is all that we can do with that, because 15 doesn't have any perfect primes in it. And that looks crummy. I don't know if I can make good braces here with this. Okay, that's not too bad. Right, there you go. That is our answer in set notation. It's negative 5 plus I root 15 over 10 and negative 5 minus I root 15 over 10. Try the next one. All right, so remember that I said make sure all your terms are on the same side. Look at what's going on here. Look at these two, they're on the wrong side. So before we do anything, we're going to pull those over. And when we do, we get 2x squared minus 7x minus 9 is equal to 0. And then we'll designate A, B, and C. Right? So we're going to have the opposite of B, which is going to be a positive 7. X equals plus or minus the square root of 49 minus 4 times 2 times negative 9 all over 4. I'm going to work to the right here, and I get 7 plus or minus the square root of 49 plus 72 all over 4, which means x equals 7 plus or minus the square root of 121 over 4, which means I have 7 plus or minus 11 over 4, which means I get 7 plus 11. What is that going to equal? 18 over 4, which equals 9 over 2. And then I get 7 minus 11 over 4, which is negative 4 over 4, which is negative 1. So I get, in set notation, 9 halves and negative 1, just like that. All right, so the thing that you need to look for is to make sure all your terms are on the left. Also, if you're missing a term, then plug in a 0 for that coefficient. Okay? So if I didn't have an x term, then my b would be 0. If I didn't have a c term, then my c would be 0. The next thing we're going to talk about is the discriminant. The discriminant is a very specific part of the quadratic formula. It's the piece underneath the radical sign, namely b squared minus 4ac. It tells us, by its value, it tells us about the number and types of solutions. Okay? And it depends on its value. So let's talk about this. If b squared minus 4ac is a negative value, then the equation has two complex solutions. Go back and look at slide, let me see if I can get there. Guess not. Go back and look at slide 1. Notice that we had an I in that answer. We had an I in that answer. See how we had this I? Okay, that means we have complex solutions. So if we evaluate b squared minus 4ac, remember this is a, this is b, this is c, and we plug in, we get 25 minus 4 times 5 times 2. And that gives us 25 minus 40 equals negative 15. This value is negative, right? So that means we have two complex, the number of solutions is 2, and the type are complex solutions. 2 complex solutions. Okay, let's try the next one. If our discriminant, when we evaluate it, gives us a value of 0, then we only have one real rational solution. Again, all we're looking at is the discriminant, b squared minus 4ac. So if I evaluate b squared minus 4ac for this problem, a is 1, b is 6, c is 9, then I get 36 minus 4 times 1 times 9. And I get 36 minus 36 equals 0. So because I have a value of 0, then I can automatically say, without even solving this, that I have one real rational solution. And it's actually going to be the opposite of b over 2a, the opposite of 6 over 2, or negative 3. Again, I'm looking at the discriminant, and if I come up with a situation where my b squared minus 4ac is positive, okay, bigger than 0, and a perfect square. So think of your perfect squares. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, all right, 225. If we have positive and a perfect square, then the equation has two real solutions. Again, we're just looking at this piece of the formula. That's all we have to evaluate to be able to tell this information. It's so easy. Okay, so what we're going to do is we're going to identify A, B, and C, and we're going to plug it into b squared minus 4ac. So b is 2, so I get 2 squared is 4, minus 4 times 12 times negative 4, and that gives me 4 plus 192, which equals 196, which is a perfect square. It's positive and perfect. So that means I'm going to have 2, that's the number of solutions, real, rational solutions. Okay. Then our last scenario, again, we're just looking at the discriminant. One more time, just the discriminant, b squared minus 4ac. This tells us information about the number and the types of solutions. If when we calculate it, we get a positive non-perfect square, so it's any number that's greater than 0 but not a perfect square, then we're going to have 2 because that comes from the positive, and then the real irrational comes from the non-perfect square. So let's see what happens, see what this looks like. So here's A, B, and C, and we're plugging it into b squared minus 4ac, and we get 25, that's 5 squared, minus 4 times 2 times negative 6. And when we do that, we get 25 plus 48, which gives us 76. This is positive, but it's not perfect. Whoops, perfect. So we're going to get 2, that's because it's positive, real, irrational solutions or roots. Irrational. Let me fix that while I'm erasing. Solutions. And that be it. You're going to do a homework sheet tonight, the quadratic formula. This should be 2 through 14 even. 2 through 14 even, sorry. And then 15 through 20 all. That's due tomorrow, along with all your corrections. Also, Quest corrections are due tomorrow, which means that you have to have a separate sheet of paper. You have to put the problem down. You have to show all your work. And you have to turn in the original Quest and the separate sheet of paper in order to get credit. It's tomorrow, it's due tomorrow. You'll have the 30 minutes in class to work on it. So, but I don't know that you can get it all done in just 30 minutes. So work on it Hopefully you've been working on it last night and work on it tonight, and then you'll have some time tomorrow to do it. All right? So, we'll talk with you later. Bye.